absolute max min, I will also indicate the relative also on this interval. So in general, where the question is saying, find the absolute max and absolute min values on the given interval. Yeah, but I will also identify the relative max min. Okay, so find max min. So the problem is asking for the absolute, but I will identify and specify which one is a relative as well. Good. So I will start the table, find the domain, etc., 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 etc. But in this particular case, the domain is what we are given. We don't have to do anything else. I can get to a next page, it seems like. Okay, so on this situation, specifically, it's slightly easier. I don't have to think about the domain. Unless I think that the function is undefined somewhere in between, but this is not a tricky question. So we are told 0 to 3. It is mandatory, like we did before, on all our tables, we determine the endpoints. These were not the endpoints in this case because they were infinities. But in all the situations, we always determine the endpoints. We call it the end behavior. Okay. So eventually I will determine the function value at 0 and 3. I have to. I will start by determining the derivative right away. Can anyone tell us the derivative? At least get us started. Anyone who hasn't said anything today?
Would it be 1 over 2x minus 1?
How many shoulders will allow me to cry? It's the quotient rule that we have to apply.
Oh.
We have a function at the top. We have a function at the denominator. I know it's very tempting. I know it's tempting, but we can't.
You can, is 1 times.
Yes. X squared minus x plus 1 minus?
Minus x times 2x minus 1.
Very good. And the denominator is squared.
Squared.
I know it's very tempting. Don't try anything that you haven't seen in class. Most probably it's wrong. Okay, moving on. So I will try to simplify as much as possible. And I don't know what to do with this. Because remember, I need to find f prime of x equals 0. I need to find the solutions for this, or f prime being undefined. So talking about this for a moment, and I'll come back. X squared minus x plus 1 is a piece of x cubed plus 1, which is x minus 1 and x squared minus x plus 1. This is never 0. This one. Let's say you don't remember that from algebra. Well, when I try to find when I try to apply the quadratic formula, I get 1 plus or minus the square root of 1 minus 4ac over 2a, not real. So this is always a positive number, never 0. Okay? So this situation is gone. But I do have to simplify it as much as possible to see if it has solutions, if the equation f prime of x equals 0 has solutions. So I have x squared and minus x and plus 1 minus 2x squared and plus x over x squared minus x plus 1 squared. Luckily, at least something simplifies. I'm going to do this so you know where it's continuous because, of course, I had to say other things in there. So this is negative x squared and plus 1, quite nice, over x squared minus x plus 1 squared. Okay, now what? And you know what I'm going to do? Anyone? Anyone? Kush, how do I continue? Say it again. So what will anyone do here now?
Set it equal to 0.
So factor out -1 and get x squared minus 1, x squared minus x plus 1 squared. And then what will I have to do to make my life as easy as possible? Anyone?
You can make the top x plus 1, x minus 1.
That's all I needed. So now when I thank you very much. So, Mickey. So now I know the solutions. I don't have to work too hard after that. So what is it? What are they? Can anyone give us?
-1 and +1.
Very good. That's it. -1 and +1. Great job. So I will put them in the table. Okay. +1, -1. However, -1 doesn't fit. That's even better. Thank you very much. Okay. At this point, I have to study the sign of the derivative and determine this, this, and this. Okay. So when I plug in 0, it's very clear. 0, 0, 0, 0 over 1. This will be 0. When I plug in 1, I have 1 over 1, which is 1. And when I plug in 3, I get 3 over 10 minus 3, 7. 3 over 7. I'm checking that. So the top is 3. One more time. 9 plus 1 is 10. 10 minus 3, 7. Good. Okay, and now we have to study the sign of the derivative. This is the derivative. Which portion of everything we see here you will not worry about the sign? So there is a negative, there is a factor, and another factor in the denominator. Which of all these you're not going to waste your time to plug in?
The denominator.
Absolutely. It will be a waste of time. Why it will be a waste of time to plug in anything in the denominator?
It's squared.
Of course. So I'm going to plug in 0 because that's all I need here, and I'm going to plug in 3. Just the sign. When I plug in 0, what will be the sign of this expression? Do not forget the minus in front. Just the sign of this expression when I plug in 0.
Negative.
So, yes, positive because I have 0 minus 1 with minus in front. So this is positive. Now I'm going to plug in 3. 3, 3, 3, 3 with minus.
Negative.
Very good. As you know, now the moment of truth. If these two don't work well together, I'll go back to the drawing board. I have to. The derivative is positive. What should the function do?
Increase.
Is that correct?
Yes.
Good. What should the function do here?
Increase.
Is it from 1 to 3 over 7?
Yes.
Perfect. Okay. So now, I am not graphing the function. I'm just presenting the y values. So the y value here is 0. Then it goes up to 1. And then it comes down to 3 over 7. Again, I'm not graphing the function. But at this end is 0. Somewhere in the middle is 1. And then at the other end is 3/7. So now, what do we conclude about 0, 0?
Absolute minimum.
Very good. Absolute minimum. What do we conclude about 1, 1?
It's the relative.
Relative maximum.
Relative, but it happens to be absolute as well. Max. Very good. What do we conclude about 3 comma 3 over 7? 3 comma 3 over 7?
It's nothing.
Nothing. It's not a relative max-min. It's not an absolute max-min. It's nothing. Very good. This is how we study a function on a closed interval. Would you like to look at a log function?
Yes.
Okay,
Yes.
very good. I'm looking at 2 different ones. I'm going to copy both and you will choose. One of them with a log is f of x equals x minus natural log x on 1/2 x2. The other one is natural log of x squared plus x plus 1 on -1, 1. And in case you are thinking of an exponential, x e to negative x squared over 8. This I put once. You probably will see it on a test review some semesters ago.
So, can we do 2 of them? I know you said they're pretty long, but timeline.
No, the trig functions. I didn't even choose a trig function yet, but the trig functions are long. These are not as long as the trig functions. You choose. Which one?
The middle one.
You said the middle one?
Mm-hmm.
Okay, let's start with the middle one. We can come back, and if you want to choose another, that's fine. Okay, so we are choosing f of x equals natural log of x squared plus x plus 1. And we start with x. No discussion. The discussion on domain is cut off from this particular problem because we are given the domain. Otherwise, we will always start with the domain. Good, so f prime. Can anyone remind us? Someone I haven't heard yet, like Killen I haven't heard. I think Gia didn't, or maybe she did. Sorry if I forgot. Javon, Gabriel, Oscar, if you want to say something. Anyone? Yes, I'm ready.
Natural log is 1 over, is it 2?
That's
no, just 1
the
over
square
x
root. That's the square root.
Okay.
The square root prime is 1 over 2 the square root of x.
Okay, then this one's just 1 over x squared plus x plus 1, then plus 2x plus 1?
Multiply. Yes, 2x plus 1 indeed. Very good. So this is basically 2x plus 1 over x squared plus x plus 1. And again, this piece comes from x cubed minus 1, which is x minus 1 and x squared plus x plus 1, and this will never be 0. So the derivative will never be undefined. But it will be 0. So f prime of x, never undefined. But f prime of x can be 0. Can anyone give us the solution? When is this 0? When x is
1/2? No.
yes, -1/2. At this point, I have to put in the original function these 3 values.